So here's our first little circuit. It looks like I have two 1.5 volt batteries in series. If I put a voltmeter right here, how many volts will it measure? A, 1.5, B, 3, or C, 0? And convince me. What do you think? I've heard 0, I've heard 3.
Because you're going on 2 ski lifts.
I can't hear you.
You're going on 2 ski lifts.
I can't. Oh, is it out now? Okay.
You're going on 2 ski lifts in between the...
Okay. This is going to be 3 volts because this is like going on 2 small chairlifts. The first chairlift gets you halfway up the mountain of 1.5 volts. The second chairlift gets you halfway up the mountain of 1.5 volts for a total of, everybody? So if I need a 3 volt battery, I can invest in a 3 volt battery that uses a different chemical reaction, but for the most part, we just link batteries in series. If you see batteries that are end to end, positive to negative, they're in series. Adam, I heard you say 0. You know what would be 0 volts? If they were facing each other. Of course, if you put the batteries in the wrong way when you're replacing them on a remote or whatever, you've all learned, doesn't work. No voltage. Okay? In many portable devices, CD players, do you even know what CD players are anymore? Maybe, okay, people don't. Flashlights are in particular, 2 or 4 batteries or more are used in series, as in the diagram above. What this does is it increases the total voltage. However, because current equals total voltage divided by total resistance, as that gets bigger, what happens to the current? Which means the batteries drain faster. Okay, you can bump the batteries up, but you're also going to be bleeding the charges from the batteries faster. No, faster. Like in less time, it won't last as long.
But you have 2 choices for the battery, so it'll last the same time as one.
No, because the current going through each battery is higher. Okay, just hang on. Yeah.
So if you just have something that uses one battery,
Yeah.
that's the battery that you plug it in.
Yeah. Sorry. It depends on the circuit and on the device. For a flashlight, probably not. In fact, as a matter of fact, in a pinch, if I've been desperate, if all I've had are AAAs, I can wedge some tin foil on either end and cram that into a AA slot. It'll work. It'll drain the AAA faster because the AAA doesn't have as much charge to begin with, but it'll work. I've done that before when I was desperate to get something to open or whatever. Okay. Here's what we really want to do. Here, how many volts do you think you would measure right here? How many volts are going through this resistor? Well, if we ski this ski hill, how many volts? If we ski this ski hill, how many volts? What's going through this resistor here is 1.5 volts. But because each chairlift is only having to supply half as many skiers, these batteries will last twice as long because they're each only contributing half the charge. What you'll often find is if you have a 4 battery system, if you look really close, if you're putting in 4 batteries, 2 of the batteries will be in series, another 2 will be in series. That gives you 3 volts like here, but also lets the current last, gives you twice the charge. That will last the same as 1 battery with 3 volts, as opposed to draining it twice as fast. And so that's why you'll often see them in the positive, negative, positive, negative alignment. I almost guarantee those 2 are in parallel, or sorry, are in series, and those 2 are in series, and together they're in parallel. That's really the lesson, but let's look at some examples. So, rechargeable batteries. They're recharged by connecting them to a cell that forces current back through the cell. So this is very applicable to you. If we connect a 1.5 cell facing to the right to a 6-volt charger facing to the left, then first of all, what direction will the current be flowing through this ammeter? To the left or to the right? I've heard someone say left, I heard someone say right. Which way is downhill? Where's the highest point in the ski hill? Right here. So that's downhill. I guess what's happening is people are going up a 6-volt chairlift, riding a chairlift partway down 1.5 volts. How many volts are going right through here? Because you gained 6 and you lost 1.5. And that's almost always put there just to bleed off the remaining voltage. This voltage, this energy per coulomb goes into recharging the battery. The rest is put through a protective resistor of some type. So what would be the direction of the current as detected by the ammeter? I think it would be going to the left. And what will be the net voltage? 4.5 volts. Gain 6, lose 1.5. Is that all right? Does that explain your answer? I think we kind of have. So in terms of my ski hill analogy, cells, turn the page, in series are like 2 chairlifts taking you to the top of the mountain. Cells in parallel are like 2 chairlifts, both of which lead to the top of the mountain. Some skiers use one chairlift, some skiers use the other chairlift. Opposite cells are like 1 up chairlift followed by 1 down chairlift, and the up chairlift is the biggest voltage. Pardon me? You're going to find right around now is where my ski hill analogy starts to break down a little bit, but it still works pretty good. Okay? So by properly labeling the circuit, which way is downhill, we can easily find the difference in voltage at various points. Remember, positive means higher, negative means lower. Current flows downhill from positive to negative. If you go through a resistor from positive to negative, you're losing voltage. If you go through a resistor backwards from negative to positive, that's gaining voltage. That would be like crab walking your way back up a ski hill. Doable, but hardly anyone would do that. Okay? I think I have, yeah. This is well beyond what I'm going to ask you. In fact, I think I stole this from a university textbook. But we can handle this. So you ready? First thing I noticed, 2 batteries. Do you see them? How big is the left-hand battery? How many volts? What about the middle battery? You know what? That's downhill. Right? So it looks like one of the questions it wants me to answer is which way is the current in this arrow? Definitely going that way. Okay. Ooh, it says current is flowing in this direction at location Y. So I guess if I have current going this way and current going this way, which way must the current be going in this right-hand wire? Gotta be going that way. So that's downhill. That's downhill, that's downhill, and I guess that is uphill. All right. Step 2 was try and find total current leaving the battery. Well, I don't think I know total current leaving this battery, but wait a minute. I do see current here. Let's see if we can play with that a little bit. Caleb, how many amps right here? How many amps right here? Ooh, how many volts in this resistor? It's going to be I times R. Well, let's try skiing this ski run right here. And why did I pick that ski run? Because I know this hill. I don't know that hill, but I know this chairlift. I think I can make this work. Let's go see. Let's start at the top of the chairlift. How high? Whee! Ooh, how many volts do I lose going through here? How many volts must I lose going through here then? Got to be 2.5, right? Has to be. All right. Do I know two things here? Do I know two things here? Okay, let's ski the other run. Let's try skiing. From here, this way. I'm avoiding that middle one because I'm a little scared to go up the chairlift. I will if I have to, but I'm a little uncertain. So let's see if I can avoid that. So, Camille F., how high is this chairlift? How many volts? I don't know how many volts. How many volts? Did that get me to the bottom? How many volts must I have lost going through here? How many volts did I start with? I lost something. I lost 2.5 more. That got me to 0. You know what? This has got to be. Otherwise, that ski run does not work. I know two things. How many amps? Oh, Ronan, how many amps right here?
1.
How many amps going this way?
0.5.
How many amps here then? Got to be 1.5 amps. Oh, how many amps going through this resistor? I know two things. What is mystery resistor R equals question mark? V equals I times R. I guess R equals V over I, he says. Oh, equals 1 amp. Have I answered every question mark? I think I have. There. Okay. The ski hill thing I've taught you, it really works surprisingly well. Even for really complicated stuff, don't panic. There will almost always be at least one ski run you can do. And when you do that one, often that will give you another ski run that you can do. And when you do that one, often give you another ski run that you can do. I think that was the lesson, was it not? Yep. So, you can try question 2. I skipped number 1. Put a star next to number 3. You can do number 3 without rewriting it. You do not need to combine things in parallel. You will occasionally need to combine a series one. In fact, I think I had to combine those 3 to solve it. But otherwise, you can do it without rewriting it. But it's tricky, but cool. Number 3 is way tougher than I would ever ask you. Okay? 4 is good. 5 is good. 6 is good. 6, they didn't tell you the resistance of the bulbs. Make up a nice resistance and then just solve it and see which one ends up with the least amount of power or what happens to the power, because it's talking about brightness when you close the switch. 7 is good. 8 is good. 9 is good. 10 is good. 11 is good. But you got a full hour. And basically, I'm done the unit. The only remaining lesson, when do I see you? Friday, I'm going to give you a take-home quiz. In lesson 7, we're going to be a bit more accurate. Up until now, our batteries have been perfect. It turns out every battery has inside of it a tiny resistor because they're not perfect. So we'll ask, okay, let's take that into account. And we're done.